Now let's talk about the significance of the buffer solutions. Let's say you are having a buffer solution and also a non-buffered solution, and let's consider you have acetic acid and sodium acetate as a buffer solution, and you have a non-buffered solution along with the concentrated hydrochloric acid. And let's say you are diluting them, I mean you are adding water to the solutions. In this case, your buffer solution can resist the pH change up to 10 power 3 times of dilution. But in the case of unbuffered solution, the dilution will subsequently increase the pH. And in the case of HCl, even the concentrated HCl, it will lose its pH during the dilution. And this is the effect or significance of the buffer solution when we talk about the real-time use. And again here we can see tolerance levels of different aquatic animals to the pH. In the case of sea bass, it can live within 5.5 to 6.5 pH. In the case of mussels and clams, they live in very limited pH like 6 to 6.5, even 7 it is okay. For greyfish, they can live between 5.5 to 6.5. In the case of frogs, they can actually live even in the acidic condition up to 4 pH. And when we talk about the perch fish, it can live up to 4.5 pH, I mean 4.5 to 7. And in the case of snails, they are also very sensitive to the acidic pH. They can live only up to 6. And finally, the summary of this presentation is: water is a globular solvent. It has high dielectric constant and dipole effect, hydrogen bonding, which gives them unique property. Unlike other solvents or liquids, water actually acts like a larger molecule due to the presence of hydrogen bonding. And then we discussed about the pH. pH is nothing but the concentration or activity of the protons in the water. And in fact, pH can influence many of the properties, starting from the speciation of the dissolved species, solubility of many minerals, and association of dissolved species with the solid surfaces, and these are all can be controlled by the pH. And when we talk about the buffers are nothing but the solutions that can resist pH upon dilution, and this change will be relatively small to notice, and generally buffer solutions can tolerate the dilution up to 10 power 3 times. These are the references you can refer to for further reading. The book written by the Patrick and William is one of the useful book which gives complete details about the water chemistry, and the other book about the aquatic chemistry written by the father of water chemistry, Stum, and this is also a very useful book. And another one is written by the Boyd and Tucker, who wrote several books which are all considered as Bibles of the aquaculture industry, and these are all the books mainly used for this presentation, and you can follow these books for further understanding.